Hello everyone, my name is Shafi. Today in this class we are going to discuss about IP address and subnetting. Any idea what exactly this IP address and subnetting? Anyone? Okay, okay, exactly. Okay, so IP stand for Internet Protocol. Internet Protocol. It is the method or protocol by which data is sent from one computer to another computer on internet. See, now you are there. How we can be identified to you? By the name, right? By the name, we can be identify the person here, this one. Similarly, in a networking, if any device wants to be identified, any computer or any other network devices want to be identified, how we can identify that one? So there are two methods available to identify. One, we can be identified by the device name. Device name is, so for the device, we can be assigned the host name. For every device, what we can do this one. So we can be assigned the host name, that one. Okay. So with the host name, we can be identified. And another thing, with the IP address, we can be identified this one. But even if there is a host name, the backend, it required an IP address. See, host name is there only for easy method to be accessed, the easy method to communicate this one. But actually, device can be identified in the network by using the IP address. If there is no IP address to that device, suppose if there is no IP, you have not assigned or administrator is not assigned, then it's not possible to communicate to that device. And from that device, it's not possible to communicate to any other device. Because, so if you want to communicate to the device, so IP address is required. Okay. From that device also, if you want to communicate to any other device, then also we require an IP address. Because whenever you communicate, okay, source and destination information should be there in the network. Source means source IP address, destination IP address. So if you have a source and destination, then only it's possible to communicate. When you don't have the source and destination, it's not possible to communicate. You have destination, but you don't have the source. Or you have the source, you don't have the destination, then it's not possible to be communicated. Okay. And each computer known as a host. Host means what happen if any device having the ability to assign the IP address. You take any network device, okay, with to that device, if it is having ability to assign the IP address, example, laptop, can we assign the IP address? Yes. Desktop, can we assign? Yes. Can we assign the IP address to switch, manageable switch? Yes, we can assign. Can we assign the IP address to router, firewall, IPS, access point, controller, servers, like this one? If any device having the ability to assign the IP address, for that device, we can call it as a host. Okay. On the internet has at least one IP address that uniquely identified from all the other computers on the network. Means this IP address is a logical address. Okay. Now, which is the physical address? So the MAC address is the physical address. If you remember, in the last class, network devices, we have discussed the NIC card, network interface card. Every NIC card or every Ethernet port, not only the NIC card we use on laptop or desktop, but if you go to the network devices, router, switch, firewall, IPS, where you get the network port. Okay, every network port, it will be having the MAC address, this one. That's in a physical address. Now we require two addresses to communicate in networking. Remember that one? Two addresses we require. One physical address and second one is logical address. Physical address is the MAC address, logical address is the IP address. We require both the addresses to communicate here. Okay. Now what happened? IP address, it's a unique address. Okay. If any device wants to be participate in a network to communicate, and every device require an IP address, this one. Now we have two versions in the IP address. One is IPv4 and IPv6 here. The latest version in the IP address is IPv6. We have this one. Each version defines the IP address differently because of their condition. Means both IPv4 and IPv6, they provide the IP address. With both the IP address, we can communicate in the networking. Okay, but they provide differently. Both they provide IP address, but they provide differently because of their condition here, this one. Versions are released because of huge growth on internet. Why they are coming with versions here? Because in IPv4, if you go version 4, if you go, maximum it can be provided the 4.3 billion IP addresses. But now, okay, globally we have more than 4.3 billion users. Because earlier the internet was using only in few people, few organization. Now you go anywhere, we have the internet here. You take any mobile phone, you take any laptop, you take any desktop, you go anywhere. Even for electronic devices, we are assigning the IP addresses because remotely to be access the device, get the alerts, alarms, to see the status and everything. Okay, so IP address is assigning here this one. So that's the reason what happened. There are huge number of users, they are using the internet, but we have very less IP addresses in the IPv4. So that's the reason they have come up with the IPv6 version here. So here there is a difference between the IPv4 and IPv6. You can see this one. So IPv4 is deployed in 1981, but IPv6 is deployed in 1999. It's a 32-bit address, and this is a 128-bit address. Okay, this is into dotted decimal notation, means this is into the decimal format. This is into the hexadecimal format. Example for the IPv4, it looks like this one. Can you see this one here? Okay, but 192.149.252.60, 76, it looks like this one. Okay, decimal format. Okay, decimals means what? 0 to 9. Any address you take, it comes between the 0 to 9. Hexadecimal means it's a combination of both alphabet and numeric, 0 to 9 and A to F. So it's a 32-bit address. It's a 128. It's very big. Okay, length. Can you see this one? It's very big in length. Okay, address here. This it will be coming. Okay, the prefix notation, that means /24 /48 it will comes. That for that we can also call it as a CIDR value that will be discussed. Here, how many IP address you will be getting this one? Okay, 2 to the power of 32. Why? Because it's a 32-bit IP address, right? If we calculate 2 to the power of 32, it will be getting 4.3 billion IP addresses approximately here. But coming to this, it's a 128-bit IP address. If you calculate 2 to the power of 128, these many IP addresses you will be getting on this one. I don't know this calculation, frankly, to say that one. Okay, something 340 something, it's there, but I don't know exactly that one. Okay, so these many IP addresses will be getting. Okay, so that's the difference between the IPv4 and IPv6. But today in this class, we are going to be discuss about IPv4, not an IPv6 here, this one. Okay, what is an IPv4, what its classes, ranges, what different types of IP addresses are there, what purpose we use this one. Then also we have a subnet mask. What is the subnet mask? Why we require subnet mask? So that's what we are going to be discuss this one. Got it? Any questions, guys? Online?
No, sir.
Okay. Next, we'll see for IPv4. Okay. Here, bits represented by 0 or 1. So it comes into the binaries. Okay. Binary means what? Zeros or ones here. Okay. It is a 32-bit IP address. How we got it 32-bit IP address? Example, I have taken one IP address here, 192.168.100.1 here, this one. Okay. Now, this 32 bits are divided into 4 octet. In generally, octet means what? 8. Octet means 8 here. Okay, I'll come back in this one. And IP address is in decimal format. Decimals means if any number comes between 0 to 9, it's a decimal. See here, you can take 192. 1, 9, 2. It comes between 0 to 9. 1, 6, 8. 1, 0, 0, 1. Right? So in between this, we have a dots here. So that's the reason it's called dotted decimal format. IPv4 into dotted decimal format. Decimals, but we can also call it as a dotted decimal. Why? Because in between the IP addresses, we have the dots here. So in this 32-bit IP address, totally it's having the 4 octets. Can you see this one? First octet, second octet, third octet, and fourth octet, we have this one. Octet means 8. Okay. So in first octet, we have 8 bits. Second octet, we have 8 bits. Third octet, 8 bits. Fourth octet, 8 bits. So 8 into 4 is how much? 32. So that's the reason this is the 32-bit IP address. Got it? How it's a 32-bit IP address? So in a IPv4, totally we have 4 octets. Each octet contains 8 bits. 8 into the 4, it's a 32. So that's the reason it's a 32-bit IP address. Okay. Now it provides approximately 4.3 billion IP addresses. Can you see this one? Why? Because 2 to the power of 32, if you calculate, it comes around the 4.3 billion IP address. And this IPv4 address is designed by IANA. Can you see this one? IANA, Internet Assigned Number Authority. This is an organization where they have designed and developed this IPv4 address. Okay, and there is a range for this IPv4 address. It starts with the 0.0.0.0. So all 000s, and finally we have 255, 255, 255. That's it. The range starts with the 0 to 255. There is no 256 here, this one. Okay, we have only till 255. This is the range they have provided here in this one. Next, this IPv4 provides different types of communication. There are 3 different types of communication the IPv4 address supports. One is the unicast, second one is the broadcast, third one is the multicast. Unicast means one-to-one communication. One-to-one communication. Broadcast means one-to-all. One-to-all means, for an example, the best example for the broadcast is your television, radio, FM. So if you tune it to the particular channel, range, ratio, everyone can access that, right? So whatever the radio frequency or the FM frequency or the any television you have this one, everyone can. For example, channel number 921. Everyone go to the 921, automatically you'll be getting that one. So that's what the broadcast. It will be sending to everyone here, this one. Multicast means one to many. It's a group. Okay, it will be sending only to the particular group. For example, in the WhatsApp, you'll be creating a group. Okay, if you post it something on that one, it goes to the everyone in the person who is into the group here, this one. Like this one, we have a multicast. So in a networking, we have different types of communication. Unicast, multicast, broadcast, anycast. Okay, this is how we have this one. But IPv4 supports, it supports unicast also. Suppose if there is any communication in networking, one-to-one communication, it supports. If there is any broadcast also, it supports. If there is any multicast communication also, it supports. So here it has given some IP address 224.0.0.0 to 239.255.255. This is a multicast IP address. We'll discuss later what exactly this multicast IP address, where we use this multicast IP address in networking. Okay, so this is about the IPv4 address here. We have this one. Any doubts? Next, its classification means how many different classes we have in the IPv4. So totally we have the 5 classes: class A, class B, class C, class D, and class E. We have this one. The range start from the class A. Actually, it's not 1, it's a 0 here. Let me take it here as a 0. Okay, it will be like this one, 0 to 127. Okay, class B start with a 128 to 191. Class C start from 192 to 223. Okay, class B start with a 224 to 239. Class E start with a 240 to 255. So this is how the classes we have this one. Okay, now for an example, if I write like this 150.15.0.0, which class IP address is this? 150.15.0.0. How you can say it's a class B?
Because number starts from class B, number is starting from 128. So it's almost 150. So we can consider as class B.
Okay, so by looking this first octet, you are telling it is this class B?
Yes.
What about this class second octet? $15, which comes in the class A.
So it contains both class A and class B.
It comes only in one class, right? It will be not coming into the 2 or 3 classes.
So it will be class A.
No, it's a class B only.
It will be class B.
Yeah. Always you have to look the first octet. Let it be the other 3 octet. It can be any number here. Don't look into that one. What second octet, third octet, fourth octet, you have this one. Just look the first octet here. The first octet number is 150. The 150 comes in the range where? Between 128 to 191 it comes. So then it's a class B. How you can identify the IP address, which class is this one? By looking the first octet. Or okay, only you have to look the first octet. By looking that one, you can identify which class is this one.
Sir, what about the second number? Can we ignore?
Yes, yes. To identify the classes, you don't look the other octets. Look only the first octet, first number. Let it be the second, third, fourth. It can be anything. Don't worry about that one. Got it?
Yes, sir.
Okay. So that's how we have the ranges for every classes here. Now, for only these three classes, A, B, C, we have a concept of subnet mask. We have a concept of what? Subnet mask. We have this one. But other two classes, D and E, we don't have the subnet mask here. Okay. Now, what is the default subnet mask for the class A? For an example, 255.0.0.0 for the class A. And for the class B, 255.255.0.0. And for the class C, 255.255.255.0. This is for class C. So these are the default subnet mask. Default means between this range, any IP address you assign, okay, sometimes only for the Windows I'm talking about, okay, automatically takes an IP address, subnet mask, because the operating system, Windows operating system, have the priori knowledge. Priori knowledge means automatically it can identify what class is this, what is the default subnet mask, this one. Okay, so this is how the default subnet mask we have. For the class A, 255.0.0.0. For class B, 255.255.0.0. For class C, 255.255.255.0 here, this one. Got it? Okay, that's how we have the subnet mask now. Now you can ask one question, how we got it this 255 number here in this octet? So totally how many octets we have in the IPv4 address? How many octets?
So in one IP, 4 octets.
4 octets we have. Each octet contains how many bits?
8 bits.
8 bits we have, right? 1, 2, 3, 4, 5, 6, 7, 8 bits we have this one. Now every bit having its own value. How the value we got it? This is how we got 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. This is how the value we got it here, this one. Every 8 bits we have in each octet, and every bit having its own value. The value we have got it like this one. Now, anything power 0 is how much?
1.
Anything power 0 is always 1. Now 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. 2 to the power of 7 is 128. Okay. 128 plus 64. 192. 192 plus 32.
224.
224. 224 plus 16.
240.
240. 240 plus 8. 248 plus 4. 252 plus 2.
254.
254 plus 1.
255.
255. That's how we got it 255 here. The maximum value in the octet is how much? 255. Because here we calculate in bits. Totally how many bits we have in the IPv4 address? 32 bits. So totally how many octets we have? 4 octet. Each octet contains how many bits? 8 bits. Every bit having its own value. The value we have got it like this one. If you calculate all the bits, so maximum value is how much? 255. That's how we got it the 255 in the subnet mask. Got it? Guys, are you following?
Yes, sir.
Okay, so that's how we have the subnet mask here, this one. Now this subnet mask we have only for the class A, B, C here, this one. Because in networking, if you want to assign the IP address to any of your devices, only you have to use in these three classes, A, B, C. As the administrator, you have a control, means something you want to assign or change it. Only from these three classes you can be assigned. D and E don't have the permission, which is reserved for different purpose. So D is reserved for the multicasting, okay, and E is reserved for some research and development purpose here, this one. What is this multicast? We'll discuss later, not now here, this one. Okay, so that's the reason we have the control of only these three classes A, B, C. So that's the reason we have the subnet mask only for the three classes here in this one. And these are the default subnet masks. The default subnet mask means, okay, so here in the class A, the first octet is completely reserved for the network. So here generally we get like this one, N dot H dot H dot H. In a class B, N dot H dot H. In a class C, N dot H, where N stand for network bits, H stand for host bit here, this one. I'll come back on that. What is this network bit and host bit here, this one. Got it clear in this one? Any doubts, any questions?
No, sir.
Okay, so I'll just go to my laptop in network sharing center. For that, what you can do, this one, you can go to the control panel. You can type control panel. Okay, in a control panel, you can go to network and internet. Then you can go to the view network status and task, where it displays all your network information. Okay, here change adapter settings. If you go, it displays in your laptop or desktop how many Ethernet cards are connected, whether it's connected or not. The cable is connected if it is a wired connection. Now here you can see, so the cable is unplugged because I have not connected any cable here, this one. So you can ignore this two, VMware, because these two options I'm getting because in my laptop VMware client application I have installed. Because of this, I'm getting that adapters here. But in general, one you'll be getting, if it is a laptop, one you get the cable, the Ethernet port, another you'll be getting the Wi-Fi port. Okay, wireless port you'll be getting. So now here, now I have connected with the Wi-Fi, but I don't have any cable. I have not connected. I have not connected through the Ethernet port here, this one. Okay, so this is how you can able to access your network connections here. So from the control panel, or you have the one more options. What you can do, this one. So you can go to the run. This is the shortcut. Okay, there is another method also. We have this one. Okay, which is the another method is here. This is your network sharing center. Okay, it means whatever the network you have connected. Now this is, I'm connected with the wireless. If you have connected with the wired, it will be display one computer over there. Just right click on that one, select open network and internet settings. So it goes to the your adapter options or network sharing center. You can go. So it will be display here. This is the another method how you can able to be access. And the one more thing is just go here, type, go to the go to the run. Go to the run, type ncpa.cpl. Okay, go to the run, you just type ncpa.cpl. This is the shortcut to access your network sharing center. See, now I can able to be get into the network sharing center. So here I'll just go right click, properties. And here you have the IPv4. Can you see this one? Internet Protocol version 4. Select on that, go to the properties, or you can double click on that one. You'll be going to this one. By default, you'll be getting this option. Obtain IP address automatically. Now you have to select use the following IP address. Means you have to assign the IP address manually. That's called static IP address. We can say that one. So now you can assign the IP address. For example, I'll be assigned 10.0.9.120. Which class IP address is this? Class A IP address. How you can say that it's a class A? You have to look only the first octet, 10. 10, it comes between the 0 to 127 here. See now, IP address we have, subnet mask we have this one. I'll just click on here, automatically take the subnet mask. Now, what is the default subnet mask for the class A? 255.0.0. Yes. So see, I'm just clicking on this. See, automatically it has taken this one. This is called default subnet mask. So why it's taking, the Windows operating system is having some network knowledge, priority knowledge. Based on this, it will be automatically selecting the subnet mask. Suppose if it is a subnetted network, you have to change it manually. Okay. So that's how we have the class A. Now, let me select some class B here. 150.15.6.0. Now, which class IP address is this? B. Now, this time we can see this one. 255.255.0.0. We have this one. Now, go back and assign the class C here, this one. 192.168.100.0. See? 255.255.255.0. This is the default subnet mask for the class C here, this one. Got it? Got it? So that's how we have the classes, it ranges, and subnet mask here, this one. Okay. So in the subnet mask, we have the network portion and host portion. Means wherever it is written 255, that's called network bit. Wherever it is written the host portion 0, that's a host bit here, this one. So in the class A, how many bits reserved for the host? How many bits for the network and how many bits for the host?
8 for the network and 24 for the host.
Yes, network is equal to 8, host is equal to 24. In class B, how many bits for the network? 16 bits for the network, 16 bits for the host. In class C, how many bits for the network? 24 bits for the network, 8 bits for the host here. So always you have to look for the host bit here. Okay. So host bit is equal to 2 to the power of 8 is how much? 256. 2 to the power of 16 is how much? 60. Something 16 million it comes. No, sorry, 65,000. It comes around 65,000. 2 to the power of 24 is how much? Then 16 million you'll be getting that. Got it? So in a class C, we get only 256 IP address. How many IP address we get in the class C? 256 IP address we get it. Class B, 64,000 IP address we get it. In class A, 16 million IP address we get it here. Got it? In a class C, we get very less IP address because 3 octet reserved for the network. Only 1 octet is left for the host part. Very less bits reserved for the host. So less IP address we get. Class B, we get more IP address. Class C, we get still more IP address. Now, which class you can use for the communication? A, B, C. Yes, you can use any class here. Depend on your requirement. For an example, in your company, you have only 50 to 100 users. Then you can go with the class C. More than 250 users are there. Because in a class C, we have only 256, right? In that scenario, what you can do this one? Then you have to go to the class B. More than 65,000 users are there in your company. Then obviously you have to use class A here, this one. So you can use any class. A, B, C, any class. Depend on your requirement, you can use that one. Got it? So here same thing, subnet mask differentiate network portion and host portion. 1 represent network, 0 represent host. Means 1111, all 11 we have, 255 will get. 00 means we have host part, we have this one. This is, for example, n.h.h.h means 255.0.0.0. So this for class A, this for class B, and this for class C, we have this one. Same CADR value we have, classless inter-domain routing, allow as a single IP address and subnet to be used to reference a group of addresses. Means again it defines which class, like how many bits reserved for the network. So which defines in the CADR. When we do the subnetting, we'll discuss the CADR value here. Okay. Next, we have subnetting. Okay, that subnetting we'll discuss later, not now. Okay, in this one, what happened? This one, subnet mask, we have this one. Okay, what is this subnet mask? Now you have IP address, right? And you have the subnet mask. What is this subnet mask? So we have an IP address. IP address we use for what? Identification. Identification of device in the network here. Then what is this subnet mask and why we require this subnet mask? What is the use of this subnet mask? Example, I'm having two PCs. PCA and PCB I'm having. And there is a connection between the PCA to PCB. Then I have an IP address. Okay. So let's take the PCA IP address is 10.0.0.1. PCB IP address is 10.0.0.2. Now, with this IP address, is it possible to communicate from PCA to PCB? 10.0.0.1 for the PCA, PCB 10.0.0.2. Is it possible to ping? Or let me change 2.0. It's not possible to ping. Now, which class IP address is this? Class A. Okay. What guys, online, is it possible to ping or not? That means, is it possible to communicate or not?
So I think it is possible.
Sorry?
Quasi Maither, sir, this is, I think it is possible.
It's possible.
Yes, sir.
Subnet mask we have like this. What is the default subnet mask? 255.0.0 we have, right? See here, 255.0.0.0. Here also the subnet mask is 255.0.0.0 we have. Okay, one more I'll take it. Other than 150, let's take it like this. Oh, let me assign 192.168.1.1. Okay, 1.1, 192.168.2.2. Subnet mask is 255.255.255.0. Here also subnet mask 255.255.255.0. Now, is it possible to communicate from PCA to PCB?
Sir, now it is not possible.
No, it's not possible. With the first one, it's possible.
Yes, sir.
Okay. See how exactly communication happens. Whenever you assign the IP address, now IP address we use only for identification. We use for what? Identification. But communication happens based on the subnet mask. Okay, it will be based on the subnet mask. The devices understand whether the source and destination, they are into the same network or different network. Okay, for example, what is the source subnet mask? 255.0.0.0. What is the destination? Both are same here. So first 255, first octet I'll look. First network part, okay, first complete octet 8 bits for the network. With respect to that, what IP address we have? 10. Look the destination. What is the first network we have? First octet we have. Complete 8 bits we have this one. What is the IP address we have? 10 here. Okay. Both source and destination it's having same, right? Now it look only the network part. It look what? Only network part. It will not look the host part here. It will not look. Only it looks for network part here, this one. If the network part matches in the both on source and destination, then you can able to be communicate. Then it will be understand both they are into the same network. See here 255 first octet, destination also 255 first octet. With respect to the first octet IP address is 10. Here also 10. Both are matching here. Now you can able to ping. Now coming to this one, what is the first octet? Complete 8 bits for the network. Here also complete 8 bits for the network. With respect to that, what is the IP address for the first octet? 192. Destination 192. Next octet, completely network, all the 8 bits. Destination completely network. With respect to that, what is the IP address? 168. Here 168. Good. Next, third octet 255. Completely network. Here is what? 255 network. With respect to this, what is the IP address here? 1. But here, what is the IP address? 2. That means it's not matching, right? With subnet mask, the IP address is not matching. I'm not look the host part. I will look only for the network part. In the network part, with respect to subnet mask, IP address also has to be matched in the both source and destination. See, subnet mask is matching, but IP address is not matching here, this one. That means this is into a different network. So now it's not possible to communicate. Now how it will be understand the devices based on the subnet mask. IP address we use only for the identification, but communication happens means how the devices understand whether they are into the same network or different network based on the subnet mask. Subnet mask will be decided whether they are into the same network or different network. Now here, so yes, subnet mask is the same, but the network IDs are different here, this one. So that's the reason it's not possible to be communicate in the both source and destination here. If you, by default, it's not possible, but if you want to communicate in between, then in between we require a router. Routing is required. So if you have a routing concept, now you can able to be communicate between these two different networks. Always by default, you can communicate in the same network. Okay. It's not possible to communicate by default with between the two different networks. If you want to communicate between the two different networks, then you require routing. To do the routing, we have one dedicated device called router. That's what we'll be going to be discussed in the upcoming classes. What is router, how routing, how you can enable, how you can configure, how you can configure the protocols to do this routing, and everything we'll be discussing in the upcoming classes. Got it, this one? Now you got it. What is the subnet mask? Why we require the subnet mask? Okay, to identify whether they are into the same network or different network, to decide whether the possible or not to communicate. So for this reason, we require the subnet mask. Yes, first one possible. Why? Because first one 255, 250. With respect, IP address also same, right? 1010. Let it be the host part, anything. Only it looks for the network part. It will be not look into the host part here, this one. If the network bits and its IP address is matching in both source and destination, then it's possible to communicate. Got it? Guys, online?
Yes, sir.
So that's how
sir.
we communicate with the subnet mask. Next, we have a different types of IP address. Here you can look into that one. Okay. So different types of IP address we have. That MAC address comes, that we'll discuss in the OSL here, that one, where the MAC address comes here. Okay. Huh? 2P, even MAC address also required. Yes, in the next class, we'll discuss about that. In the OSLAS, we'll discuss where the MAC address, where the IP address comes and everything, how it will be. No MAC address which is already configured, burnt right on the MAC address in the manufacturer. We are not assigning any MAC address. We just assign only the IP addresses. Now we have different types of IP addresses: private IP address, public IP address, loopback IP address, and APIPA here. So what exactly these addresses? We have in a class A, B, C, we have, right? In a class A, starting from 10.0.0.0 to 10.255.255.255 in a class A. And in a class B, 172.16.0.0 to 172.31.255.255. It's in class B. 192.168.0.0 to 192.168.255.255 in class C. In every class, they have reserved some range. In a class A, 10.0.0.0 to 10.255.255.255. In a class B, 170.16.0.0 to 170.31.255.255. In class C, 192.168.0.0 to 192.168.255.255. They have reserved this IP address as a private IP address. As a what? Private IP address. And this private IP address is free of cost. Not required to pay for anyone. Rather than this range, if you take any IP address, that's a public IP address. We have private IP address, then we have the public IP address. This public IP address you'll be getting from the provider. Whenever there is ISP, right, Internet Service Provider, you are taking the connection. Okay, when you take the connection from the ISP, the ISP will be providing the public IP address. To communicate over the internet, you require what? Public IP address. Now, private IP address, you use your internal network. Now you have the home connection, internet. In your home, whatever the IP address you have, now you have connected 4 devices. Your laptop is connected, tab is connected, IP phone is connected. Internally, whatever the IP address you have, the private IP address, this one. Okay. And it's a free of cost. Not required to pay anyone. Now, globally, you go anywhere, any home network, any office, internally they use the private IP address. Only to go outside through the internet or over the internet, then only they use the public IP addresses. And public IP address you have to pay. That's not a free of cost. Okay, you have to pay. You have to get it that you have to pay and get it that IP addresses from the provider. Okay, so that's how we have the private IP address and public IP address, this one. So now we have the one more IP address, one more range in the class A, 127.0.0.0 to 127.255.255.255. This is your loopback IP address. This is your loopback IP address. What is this loopback IP address and why we required? What is the use of this? For an example, you are troubleshooting, internet is not getting in your laptop. So if the internet is not getting, there are many other things you can look at, whether the cable is connected or not, or wireless is connected or not, a wireless adapter is up or not. Okay, then IP address is getting or not from your DHCP server. The cable is properly crimped or not, that one. If everything is good, there is a reachability or not to the gateway. Okay, till the gateway is reachability, then maybe the issue with the provider. There are many things you can be look into that one. But there is a one more thing, whatever the NIC card you have in your laptop or desktop, now you want to verify that NIC card is working or not, that physical port. How you can verify that? Whether the NIC physical port is working or not. So for that one, okay, you can use this 127 range. what you can do, you can go to the command prompt. Okay. Here you can type ping the loopback IP address 127.0.0. You can ping any IP address starting from 0.0.02, sorry, 0 to 127.255.255.255.255. In this range, you type any IP address, any range. Okay. So in my case, now I'll go 127.0.0.0.02, or you can go with here 10.20 example 127.0.10.20. And if you give, if you are getting a reply, can you see this one? I am sending 4 packets, receiving 4 packet, 0% loss here in this one. That means my NIC card is working fine. If you want to test your NIC card physical port whether it's working or not, go to the command prompt, ping to the loopback IP address. Loop means what? It's starting from there, again it's coming there only. Loops means what in general? From where it's starting, it's coming back to the same point here. That's called loop. So now it's checking, it's pinging to its own NIC card. When it is pinging to its own NIC card, that means if you are getting a reply, your NIC card is working fine. So they have reserved to testing for this one. No, that's what how they have designed the IP address. IANA they have designed for the testing of your own this one NIC card. Got it? So that's how what you can do this one. You can be pinged to your to test your NIC card, the loopback IP address we use here. And there is a one more IP address we have that's called APIPA. The range it start with 169 dot. Only to test, that's it. We are not assigning these IP addresses. It's very big range. Yeah, complete one's IP address range 0 to 255. Starting from 0 to 255, the complete range they have reserved. It's a no, it will not assign anywhere. Not even in the private network or public network. It's not possible to assign that one. Only testing of NIC card, not pinging. No other. No, that one. NIC card. So now there is another range called 169.254, sorry, 254.0.0 to 169.254.255.255. This is called APIPA. This is called what? APIPA, Automatic Private IP Address. 169.254.0.0 to 169.254.255.255. This is an APIPA range. What is this APIPA range? Now, I'll just delete this. Private IP address. Here, if you go, see, you have two options, right? To assign the IP address. See, the first you have obtain IP address automatically. By default, you'll be getting like this. That means you have to get it the IP address from your DHCP server. There will be a DHCP server. Now, this machine has to be request the IP address to the DHCP, and DHCP is going to be provide the IP address. So that is what IP address automatically to get it. Now, what happens if there is no DHCP server in the network, or due to some reason DHCP server is not working? Then what happens? I have selected to get IP address automatically. Now DHCP server in my network, there is no DHCP server, or some reason the DHCP server is not working. Then what happens? Somehow your laptop or desktop is required IP address. Then it takes APIPA range. Suppose manually you have not assigned administrator or user. Even there is no DHCP server to provide an IP address. In that case, automatically system itself, it takes one IP address, that is a APIPA IP address. Okay. And with this APIPA also, it's not possible to communicate. Okay. Now, for example, see, I'll try to assign the 127, the loopback. It's not possible to assign. See, 127. Can you see this one? See, I'm trying to assign 127. IP address starting with the 127 are not valid because they are reserved for the loopback address. They are reserved for what? Loopback address. It's not possible to assign. Okay. Okay. Also, I'll try to assign APIPA here. Can you see this one? 169. See, it's taking 169. 254. 0.2. See here, it's taking the 169, but actually it's not possible to communicate with this one. It takes the range, APIPA range automatically, this one. So that's how what happened this one. We have the IP addresses, APIPA, loopback, private IP address, and public IP address. Got it? What is private IP? What is public IP? What is loopback IP address? What is APIPA range and everything? Clear? So that's how we have a different types of. We'll discuss what is DHCP. That comes into the collaboration, not into the routing switching also. In the collaboration you will be getting, that will be discussed into that one. So private IP, public IP, loopback IP address, and APIPA finally we have. Got it? So this is about the IP address. Now you got it. What is IP address? How many versions we have? The difference between IPv4 and IPv6. Again, what is IPv4? How many octets? How many bits? Okay. Who designed this one? And how many classes we have? What is subnet mask? Why we require subnet mask? And how many different types of IP addresses we have, like private, public, APIPA, and loopback, this one. Okay. The next is subnet mask. That will be discussed in the next class. Okay, that's it for today. So next is subnetting here. What is subnetting? Why we have to do the subnetting? How many methods available to do the subnetting? So that we'll discuss in the next class. So any questions before we wind up?